Okay, so as in the last video we have discussed about capacitor, we have discussed about the basics of capacitor. Initially we discussed what is capacitor. So capacitor was nothing but it was the device which will gonna store the large amount of electric charges. Then we discussed what is charge. Charge is nothing but it is a property. It is a property due to which any other electric charge will gonna feel the force of attraction or repulsion, right? For example, if you have one charge, like you have a positive charge, right? When another charge would be coming to near to this charge, either that charge would be attracted if that charge would be negative, and that charge can be repelled as well if that charge would be same as the charge we have taken, right? So we have two types of charges, positive and the negative charge. When we put positive charges together, they repel each other, because we know that same charges will always gonna repel each other. Then we put positive negative together, they have attracted them each other, because we know that different charges will gonna attract, they'll gonna feel the force of attraction. And again negative charge will gonna repel each other, since they both are same, and same charges will gonna feel the force of repulsion, right? Then we discuss the capacitor with the help of diagram. We said we have considered two opposite charged parallel plates, right, which were separated by a very small distance d, right? The positive plate of the capacitor stores the positive charge and connected to a positive terminal of the battery, and negative plate of the capacitor stores the negative charge and is connected with the negative terminal of the battery, with potential difference provided V volt. Then the charge stored on a plate of the capacitor would be directly proportional to the voltage provided to it. And using this equation, using this statement, we made that the charge stored on the plate of the capacitor would be directly proportional to the potential difference provided to it, right? This we have discussed. The charge stored on the plate of the capacitor would be directly proportional to the potential difference provided to it, right? So when we remove this proportionality sign, we're gonna get the is equal to sign and the constant, right? Now let's see what constant we're gonna get here when we remove this proportionality sign. So q is equal to, when we remove this proportionality, we get is equal to sign, and here we got our constant, which is c, right? And again v same, right? So c here is nothing. I'm going to tell you what is this c about. So here v is multiplying, right? When it will go there, it will be divided, right? So c is equal to q over v. Now let's discuss what is this c constant, right? So this c is nothing but the c is a constant, which is also known as capacitance of a capacitor, which depends on the distance between the plates and the area of the plates and the material of the medium, but it does not depend on one thing, and that is the thickness of the plates, right? Let me write this all. This is very important in terms of MCQs. So let me write this here. This entire chapter is very important in terms of MCQs. So every single point will be considered as MCQ, right? So this C is nothing but it is a constant. It is a constant which is called, or also known as, capacitance of a capacitor. Capacitance of a capacitor. Capacitor, right? This is a constant which is known as capacitance of a capacitor. It depends on three things. It depends upon the distance of the plates, area of the plates, and material of the medium, right? What it depends on? It depends on three things, right? Depends on three things, right? The distance between the plates, distance between plates, the area of the plates, the area of plates and the material of the medium or the nature of the medium, right? Material of the medium. But I told you another thing, that it will not going to depend on one thing, and that would be the thickness of the plate. So this is very important again. This I should write with red so that it can be a disclaimer, right? Capacitance of a capacitor or the constant, right? Capacitance of a capacitor does not depend on the thickness of the plate. On the thickness of the plate, right? Of the plate. It will going to depend on three things, right? It will going to depend on the distance between the plates, area of the plates, material of the medium, but it will not going to depend upon the thickness of the plate. Or you can define the C, the capacitance of a capacitor, the constant which is known as capacitance of a capacitor, as the ratio of the charges which are stored on the capacitor and the potential difference provided to it, or the potential difference across the conductor, right? So there is another definition for it. An other definition, right? This capacitance is basically the ratio between the charge of the plate, charge of the plate of the capacitor and the potential difference across the conductor, right? And the potential difference across the conductor. Right, so we got our second definition as well. This we have not learned, right? This we have made basically, because we know that when we said the charge stored on the plate of the capacitor is directly proportional to the potential difference provided to it. When we remove the proportionality sign, we get is equal to C, where V was multiplying with C. When we made V go there, it would be divided with Q, right? So C is equal to Q over V. We know that C is nothing but it is a constant which is known as capacitance of a capacitor, right? Then we discuss what it depends on. It depends on three things. It depends on the distance between the plates, right? It depends on the area of the plates, and it depends on the material of the medium or the nature of the medium. But it does not depend on one thing, and that is the thickness of the plate. No matter how thick the plates are, the capacitance of the capacitor would not be affected, since capacitance of capacitor does not depend on the thickness of the plate, right? Then we have read another definition for the capacitance. This is nothing but we have made from here, right? We know that C is equal to Q upon V. So we can say that it is the ratio of the charge stored on the plate of the capacitor and potential difference across the conductor, right? Because of this equation, we have got another definition for the capacitance of a capacitor for the constant, the capacitance of a capacitor as well, which means the ratio of the electric charges stored on the plate of the capacitor divided by and the potential difference across the conductor is what we call the capacitance of a capacitor, the constant, right? So this is what we have discussed in today's video. We have basically discussed the capacitance. In actual, you can say Capacitance is nothing but it is the ability of a capacitor to store the charges, right? So the actual definition of this C is the ability of the capacitor. The ability of the capacitor to store the charges. Store the charges, right? This was the first definition. However, we have made our another definition as well, which is basically the ratio of the electric charges stored on the capacitor and the potential difference across the conductor, right? This is what we have discussed in today's video. In the next video, we're going to drive the unit for the capacitance of the capacitor.